Hello friends, welcome back to Coding Theory Guru. Today we are going to learn an important concept in operating system, threads. Okay. So what is a thread? A thread is the smallest unit of execution within a process. A process is like a container. Inside it there can be one or more threads that share the same resources but execute independently. Okay. Example, when you open MS Word, a process, one thread may handle typing, another may check spelling in the background, another may add to save your document. All these threads can run inside the same process. Okay. See, so first let's understand the meaning. Okay. Okay. So basically, a thread is the smallest unit of execution inside a process. Execution means running instructions step by step on the CPU. Okay. So basically, a process can have one thread or multiple threads. Okay. See example. When you open MS Word, so one thread is handling your typing and another thread is checking spelling in the background. Okay, so basically another thread is auto saving your document. So all these are threads running inside the same process. Okay, then process versus thread. First is process. Heavyweight has its own memory, code, data, stack, heap. Thread, lightweight, shares memory, code and data with other threads in the same process but has its own stack and program counter. Example, opening two MS Word windows, two processes, typing plus spell check inside the same MS Word, two threads in the same process. See, so many students get like confused here. So let's make it clear. See, a process is heavy. Okay, it has its own memory like code, data, stack, heap. Okay, and a thread is light. Threads inside the same process share the code and data, but each thread has its own stack and program counter. Okay, and in example, see, opening two MS Word applications means two different processes, and other hand, typing plus spell check inside the same MS Word means two threads in the one process. So basically, threads are like smaller tasks inside a process. Okay. Advantages of threads. See, first is faster execution. Because threads share memory, switching between them is faster. Resource sharing. Threads of the same process share code and data. Parallelism. Multiple threads can run at the same time on multi-core CPUs. Better performance, useful for applications like web servers, browsers and games. See, so why do we need threads? Okay, first is faster execution. Because threads share memory, switching between them is quicker than switching between processes. Okay. Second is resource sharing, means threads inside a process can use the same data and code, so memory is saved. Then parallelism, on multi-core CPUs different threads can run at the same time. Okay, and better performance, useful for apps like web browsers, loading multiple tabs. Okay, just like loading multiple tabs, games, graphics, music input and servers handling many users. Okay, Now see types of threads. First is user thread, managed by user level libraries, not the OS directly. Faster to create and manage, but if one thread blocks, the whole process blocks. Means see user threads managed by user level libraries, not directly by the operating system. Okay, so they are faster to create, but problem is like if one user thread blocks, the entire process gets blocked. Okay, now see kernel threads managed by the operating system. OS handles scheduling, more powerful but slower to create compared to user threads. Hybrid model combines the advantages of user and kernel threads. See, basically kernel threads managed by the operating system. Okay, the operating system scheduler decides how they run. Okay, so more powerful and but little like slower to create and manage. Okay, then hybrid model combines the advantages of user and kernel threads. See, in hybrid threads, combination of user and kernel threads. Okay, so these hybrid threads tries to use the best of both models. Okay, real life analogy. Think of a process like a company office. The office has its own building, furniture, and resources. That's the process. Inside the office, different employees threads do different tasks like accounting, HR, and marketing, all sharing the same office resources but working on different tasks. See, basically, let's like imagine a process as a company office. Okay, so the office has its own building, furniture, and resources. Okay, so that is the actual process. And inside the office, different employees threads are working on different tasks like accounting, marketing, HR. Okay, so they all share the same office but each is working independently. Okay, that's it. This is exactly how threads work inside a process. Okay, in short, a thread is the smallest unit of execution inside a process. Processes are heavy, threads are light. Multiple threads within a process share resources and can work simultaneously. Threads improve efficiency, speed, and resource utilization. See, so basically, a thread is the smallest unit of execution inside a process. Inside a process. So a process is heavy, but thread is lightweight. So threads share memory, run faster, and help in multitasking. Okay, so they improve efficiency and performance in modern systems. Okay, so that's all for today's lesson on threads in operating system. Thank you.